Welcome back, class. In this objective, we're going to continue on with linear functions, and we're going to talk about some strategies in the next few objectives to graph these linear functions. And then we'll be doing some exploring later on. But in this objective, in this video, we're going to graph using a table of values. Some of you have seen table of values before and called them t-charts, and it's the same type of strategy. Just a couple terms that you need to be familiar with that you should have put in your flashcards. Domain is the x values that you input into the situation. So again, the domain are all the x values that you input in the situation. The range is the output, what you get out of the situation, and those are always going to be the y values in mathematics. So if you hear me say the domain, we're talking about all the possible x values, and if you hear me say range, we're talking about all the y values, the outputs for the situation. Okay, so to create a graph, when you're given an equation with two different variables, what we're going to do is we're just going to pick some input values, pick some x values, so that's step one, and input them, put them into the equation, and see what they get. And every time you input a new value, you're going to solve for that new value. And then when you get your output value, you'll have an input and an output, and that will be a coordinate. That will be a pair of values. And then you're just going to plot those pairs. So here's an example. We have 2x plus 2y equals 16. So we can just take any input values that we want and plug them in. So you'll see that over here on the left-hand side. X equals 0, x equals 1, x equals 2, x equals 3, x equals 4. Take any value for the domain and plug it in. And once I do that, I'm just going to do the math and figure out what the output value is. So we have 2x plus 2y equals 16. I'm just going to take my x value, plug it in, and now I do the math. What does that actually come out to be? And most of you are saying already, well, we have 2 times 0, so that's 0. We divide both sides by 2. That gives us a y value of 8. Now on our graph over here, you don't see the coordinate point 0, 8. So we'll just skip that one for now. We'll move on to the next one. So again, we're just going to take the value and plug it in. So x value is 1, my input value, plug it into the equation, do the math, and see what the output is. And if you do this math, 2 times 1 is 2, subtract 2 from both sides, divide by 2 on both sides, you will notice that y ends up being 7. We plug the next value in, do the same thing over and over again. I'd like you to pause the video right now, and I'd like you to try to plug the remaining values into the equation and figure out what the output value is. And just like magic, here's our answers. So hopefully you came up with the same output values when you input the same values, because they should be the same values. So we see that with 2, we have an output of 6. When we input 3, we have an output of 5. When we have an input of 4, we have an output of 4. Now what I could do with these values is I can just simply plot them like our last objective. 0, 8, we can't plot, it's not on our graph. 1, 7, we might be able to just fit it on here. So 1 is saying in the x direction, which is the left and right direction that goes this way. We are going to go over 1, and then we're going to go up 7. So I'll just mark 1, 7 as a coordinate point. That is a possible answer to this linear equation. We go to the next value, 2, 6. So I'm going to go over to 2, and then I'm going to go up to 6. And mark that spot. We'll do the same thing in the next one, 3, 5. So go over 3, up to 5, mark that coordinate, and 4, 4, mark that coordinate. And what you should start seeing is you should start seeing a pattern. And that is exactly what a linear equation is. It's a pattern of answers that are going to repeat over and over and over again. They're going to change by the same exact amount, and we're going to talk more about what that change means in later objectives. So the last thing we can do is we can connect our values with a line. So right through the middle, and I'm on a computer, so that's not going to be that great of a line, but hopefully you have a straight edge and you can draw a nice straight line through there. One last thing I want to mention with this particular problem is that your input values don't have to be 0, 1, 2, 3, 4. You could actually go into the negative values as well. The negative values will work in some situations. Not necessarily this one. If we had a bigger graph, it might work. But let's say I input -2. We could still input -2. We just do 2 times -2 plus 2y equals 16. And we do the math. And what I'd like you to do is I could pause the video. I'd like you to think about where you think that coordinate point would be. Without doing the math, just try to think about the pattern that you're seeing on the graph. And try to anticipate where do you think you're going to be plotting that point. So without doing the math, if you think about this logically, if my input was -2, I'd have to be back at this value here. And if I look at the trend that's going on my line, we see that it's going down, 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 down from left to right. So if I backtrack to -2, it would make sense that my value is actually going to be somewhere up off of my graph. Pretty high value. So you can anticipate about where your coordinate point should be based on your trend. And that's one of the really nice things about linear equations. Okay, so here's an example that I'd like you to try on your own. So you are going to create a table of values. So you're going to have your input values and your output values. You could just do a T-chart and do your work off to the side. I like to show my work in my table. I think it just organizes it a little bit better. You could choose what you wish to do. So you're going to pick some x values, some input values, put them in your equation, and you're going to do the math, and then you're going to see what your output values are. So go ahead, pause the video, and then come back and check your answers. Okay, so your input values aren't going to be exactly like mine. We can choose different input values, and that's totally fine. But when we input the same value, you should get the same output. That's how linear functions work. So for my first one, I like to start off at 0. We'll plug in 0, and we're going to see what happens from there. When I input 0, 3 times 0 is 0. That leaves me with -y equals 4, so I divide by -1 on both sides, and y value, the output, is -4. So we can go to that graph, and we can plot those values. So we'll go to 0, 4. 0 in the x direction means I do not move left and right at all. I stay right here in the middle. So I'm going to go to -4 for the y value, and I'm going to plot my point. Now let's move on to the next one. Again, you didn't have to have that value, but if you did, you should have had the same output. Okay, so we have a good collection of coordinate points to plot for this linear function. So I'm just going to go ahead and go through and start plotting them. So I started off with 0, -4, then I plugged in 1, and when I plugged in 1, I got out -1, so I go over 1, down 1. Then we go on to the next one, 2. When I plug in 2, I output 2. And then I started going back in the negative direction just to show you that we can go in both directions. I plugged in -1. When you plug in -1, the output was -7 all the way down here at the bottom of our graph. And when I input -2, the output was -10 off of our graph. If our graph was bigger, we could plot that one, but for this graph, we can't plot it. So I'm just going to skip over it and connect what I can. So the last thing, like I said before, was to connect your points with a line. typically put those arrows at the end of the line because the line doesn't stop just because your graph does. That line actually continues on in both directions because we can keep inputting x values. We could keep inputting bigger and bigger x values, and we could keep inputting smaller and smaller x values for the situation. Okay, good luck with your practice and your exit ticket.